Question 25 just gives us an expression and it asks us what it's equal to. As far as the answer choices go, there are some interesting relationships here. One is that in answer choices A through C, we're being given 3.0, whereas in D through E, it's 3.2. So we'll have to decide between those two. And then the last part of the answer always has this 10, but then we have to decide whether it's going to be to the positive or negative 4, or to positive 18 or negative 18. And I'm going to specifically write out here that these are negatives of one another. So we're going to want to be really careful about that, since it looks like they might be expecting us to make a mistake with our signs. As far as the ACT math concepts involved here, it looks basically like we're dealing with exponents and possibly exponent rules, as well as the answer choices and the prompt itself are in scientific notation. And there are at least a couple different ways that we can approach this. I'll write them out over here. We have, as usual, there's going to be a concrete approach, which is going to be literally just plug into calculator and see what answer choice comes out. And then the second one is going to be the more formal way, which is going to be use our knowledge of exponent rules. Now, with this more concrete way of plugging into our calculator, the reason why it seems like we can do that here is because they're literally just giving us a numerical expression there, which we could enter all of those things directly into our calculator, and presumably it'll come up with some answer. And then all of these answer choices, even though they're in scientific notation, theoretically we should be able to match up whatever we get with one of those answer choices. So let's go ahead and start with that. I'm going to type this in, and we'll want to be careful with our parentheses and all that. But the numerator here is 4.8 times 10 to the negative 7. And then we're going to close that off, and then we're going to divide that again with parentheses, 1.6 times 10 to the negative 11. So it'll look like that, and then close that off with a parenthesis. And we get 30,000 as our answer. So I'm going to write that out. This is equal to 30,000. And at this point, none of these answers directly says 30,000, since they're all in the scientific notation. If we're comfortable with scientific notation, though, we could see that this 30,000 is equivalent to A. If we're not really comfortable with scientific notation, we could just enter these expressions from the answers into our calculator and see which one matches up. So for example, we could type in 3.0 times 10 to the 4th, and we would see that that in fact equals 30,000. So that confirms A is correct. Let's now look at the formal way of solving this, which is to use our knowledge of exponent rules. And one of the things that the ACT expects us to know as far as exponents is that when we have the same base, so let's say we have like a number, we'll just call it x as a general number, and we have some exponent, I'll just make this up, let's say it's 7, and then we're dividing by the same base. So again, we have x, and there's going to be, I'm just going to make up another exponent, let's say it's 3, then essentially what we do is we keep the base the same, and then we just subtract the exponents. So it'll be 7 minus 3, which becomes x to the 4th. Another related rule is if instead of dividing a number like this, we are multiplying the number. So if we had x to the 7th times x cubed, instead of subtracting the exponents, we're going to actually add the exponents. So this would be x to the 7 plus 3, which is x to the 10. And the ACT expects us to know a few other basic exponent rules, which go beyond the scope of this video. So I'll link to some resources that explain those rules in a little bit more depth. For now, though, this is really the relevant piece of information. Now, going back to the question itself, we can actually think about this expression in two different parts because we have this multiplication here. So we can almost think about this little piece separately to this piece over here, and we'll try to simplify this piece first, and then we'll go back and simplify that other piece. So I'm going to write this out, 10 to the negative 7 divided by 10 to the negative 11. And this is an example of the situation that we had talked about earlier, where we have the same base and we're dividing, because here the base is 10. And so what we're going to do is we're going to just apply that same exact formula. So we're going to have the same base over here, 10, and we're going to take the first thing and we're going to subtract the bottom. Now this is a very tricky setup here because we have a negative on the bottom, and this is like a classic ACT thing where they like to have us subtract negative numbers because there's a bunch of potential mistakes we could make at that point. And we also had that heads up in the beginning that we're going to have to be extra careful about our negatives. So let's be extra careful here. We have 10 to the negative 7 minus, and then this is going to be negative 11. So I'm going to put that in parentheses, minus negative 11. And that's going to have two negatives in a row, becomes a plus. So this will be 10 to the negative 7 plus 11. And notice I'm not skipping any steps here because we want to be super careful. I'm going to write out what that equals. So negative 7 plus 11 is positive 4. So this becomes 10 to the positive 4. So we have that. Let's write 10 to the positive 4. And then now we're going to go back to this other part of the expression, which is 4.8 divided by 1.6. And the thing to notice here is that this does not fall into this category of exponent rules because, first of all, we don't have an exponent on either of these, and also these are not the same base. 4.8 and 1.6 are not the same number. This is just a situation where we're going to just do pure division, 4.8 divided by 1.6. So we can pull out our calculator again. 4.8 divided by 1.6 is equal to 3. So this just becomes 3, and we get 3 times 10 to the 4th, which we saw, again, was answer choice A. Let's take a look at the wrong answers now and see how they were created. And before we do that, I would point out that when an answer choice set has pretty clear relationships like this one, then a good way to double check ourselves when doing a question is actually to do this process of just trying to quickly figure out the potential mistakes that could have led to any of these other ones. And that almost confirms that we didn't make any of those mistakes. So let's see if we can quickly do that process now. For example, with answer choice B, we can see that that answer is there because it's the negative of our current answer. And that might be an easy mistake to make if someone is trying to do this in their head maybe, and they vaguely remember the exponent rules, and they're like, well, there's a difference of negative 4 here from negative 7 to negative 11, so that must be it. And then for answer choice C, we remembered that there was this one step over here where we had to subtract a negative, and we could imagine that it'd be easy to forget to make this an addition. So if we did negative 7, instead of doing negative 7 minus 11, if we just did negative 7 minus 11, that would be negative 18. And so we see that answer choice C is predicting that mistake. Answer choice D, with this 10 to the positive 18, is the opposite of C in that sense. And one way we could get that is if instead of assuming this is a negative 7, we think it's a positive 7 for some reason, and it's like positive 7 minus negative 11, which would lead to 18. And we also saw earlier that D and E both have this 3.2 going on. And we can see why someone might get that if in this first part, they mistakenly think that they're going to have to apply the exponent rules over here, and they do something like 4.8 minus 1.6, because that would lead to 3.2. But as we saw earlier, we don't want to apply any exponent rules here. We just want to purely divide the two. So 4.8 divided by 1.6 is 3, not 3.2. All right, so now let's think about what we ultimately needed to know on this one, and I'll write that out over here, kind of running out of space, but ultimately needed to know. And if we did it the concrete way, we literally just plugged it into our calculator. So I would say there's nothing we mathematically needed to deeply understand with that. So using concrete method, nothing other than how to type into calculator. And then we saw that with the formal way, we had to know these basic exponent rules, essentially. And now let's think about the ultimate takeaways for this question, because there's actually a lot going on with this one that we can use on other questions and that we can use to understand about effective approaches to the ACT in general. The first thing is how powerful using a calculator can really be, and more generally, having this flexibility to use different ways of solving a question. Because if we first look at this question and we're not aware that we could just type it into our calculator, then it looks really intimidating in the sense that all these answers have scientific notation, The prompt itself is kind of in scientific notation. It looks like we're going to need to use exponent rules. So on the surface, it seems like we're going to have to remember and use a bunch of different math concepts, when in reality, on this specific question, we don't really have to. Now, that being said, as I mentioned before, we do want to be familiar with these exponent rules for other types of questions, as well as sometimes they do test scientific notation. So I would recommend brushing up on that stuff if you're not totally comfortable with it. And the final really interesting thing about this question is to notice how the wrong answers were designed. So we see that they were very, very detail oriented here. And in fact, we saw that for at least a couple of these answers, for example, like 3.0 times 10 to the negative 18, someone who did that essentially understood the correct exponent rules to apply. They did the 4.8 divided by the 1.6 correctly. They just forgot to make these two negatives into a positive, and so they got 0 points for the question. And it's really interesting to reflect on the fact that they included that as an answer, because it suggests once again that the ACT cares just as much, if not more, about this attention to detail than actually about understanding the mathematical concepts. And that's where this whole previewing of the answer choices to see these potential small mistakes can come in handy, as well as these alternative approaches that we could use to double check any math that we formally do. And as a last thing related to that is that notice how these wrong answers were actually predicting mistakes, specifically with the formal approach. And that tends to be how they make these wrong answers, is they will imagine how someone will do a formal approach and all the possible mistakes they could make with that. Whereas when we just confirmed or plugged it into our calculator, we saw that there wasn't really any answer choice there that was tempting at all using that technique. So that's another benefit of having this flexibility with problem solving. All right, so that wraps things up for this question. Let's go on to question 26.